This PowerPoint presentation is going to be on mixture/dilution problems math using the Parsons square, I believe it is called. This is not on a formula sheet. It's something I've found on the internet that's helpful for solving these problems. When you're mixing two different percent solutions together to get a different percent solution. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the proper math and the correct answers. This is a study guide to help you learn. If it does, that's great. So this is the Parsons square. This is used when you want to combine two different solutions of different percentages and create a new solution with a specified percent. So you're going to combine two solutions with a different percentage to make a new solution of a percentage predetermined. All right, so to do this, it looks a little complicated, but hopefully I can explain it in a way that makes sense. All right, so I'm going to try to explain this as best I can. So for the Parsons square, we're going to start on the left side of the square where you have the solutions. So A and B are going to be your starting solutions. So you have two solutions of varying percentages, and that's going to be on the left, A and B. All right, so you're going to take these two solutions of different percentages, A and B, and you're going to combine them together to make a new solution, C, that already has a predetermined percentage. So C already has a starting percentage that you want A and B added together to equal a new percentage on C. And then to the right on the square, we have parts. So D and E. So that's going to end up being how much of each solution A and B you're going to need to make C. So another thing to notice about those charts is there are arrows. To solve for A, you're going to follow the arrow down. It's going to be equal to the parts of B minus C. And then for B solution, you go up, and to find the parts for that is going to be equal to A minus C. And on the next slide, we're going to add another step because we're going to be solving for gallons and not parts. So again, our solution of C, we're going to be making a certain amount of gallons of that solution. And once you solve for D and E, you're going to multiply D times the gallons divided by the parts of D and E added together. And to solve for E, you're going to multiply it by the gallons divided by the parts of D and E together. Like I said, it's not the easiest sounding thing to do, but once we put it into practice, it actually is pretty easy and makes sense. So let's get into our first question. How many gallons of a 30% acid solution must be added to how many gallons of a 70% acid solution to make 50 gallons of a 40% acid solution? All right, so we have our little chart down here for how we're going to do our math. Like I always like to do with all math problems, is pull my known and my unknowns out. And I'm going to go ahead and do all the labelings as well. So in our known column, we have the solutions, so A and B solutions. We know our target percentage, and we know our gallons. And what we don't know at this point is how many parts of each solution it will take to make the new solution. So we'll plug everything in to our known and unknowns. So I got solution A is 70%, solution B is 30%. Again, your ending solution is 40%. We have 50 gallons, and we're looking to solve for D and E. Solve for D, it's A minus C, and to solve for E, it's B minus C. So 70% minus 40% for D, and for E, it's 30% minus 40%. Now, with these problems, you don't do negative numbers, so once you solve, you just drop the negative. So you have 30 parts for D and 10 parts for E. Now we're going to solve for gallons. And you see I've changed the little formula down in the corner for gallons. So you have your 30 parts times 50 gallons divided by the sum of both parts, so 30 plus 10. And to solve for E, you have 10 parts times 50 gallons, again divided by the sum of both parts, 30 plus 10. So you had 1500 divided by 40 for D, and for E you have 500 divided by 40. So we're going to do your math and division. And D is equal to 37.5, and E is equal to 12.5 gallons. Remember when looking at your chart that A is equal to E and B is equal to D. Therefore, you need 37.5 gallons of the 30% solution, and you need 12.5 gallons of the 70% solution. So that's what you'd have to combine to make 50 gallons of a 40% acid solution. And on checking the math, you can do the 37.5 plus 12.5, and that equals 50 gallons. All right, let's jump right into another one. How many gallons of a 9.2% solution must be mixed with a 3.6% solution to make exactly 250 gallons of a 5% solution? So we're going to do our knowns and unknowns. And again, I put the little chart down here, and we're going to pull out our knowns. So we know our solutions. So A, B, and C. We know our gallons, and what we're looking for is the parts, D and E. So you have a solution of 9.2% for A. For B, you have a 3.6% solution. For C, you're trying to make a 5% solution, and you have 250 gallons. So let's go ahead and solve for D and E first. So D is equal to A minus C, and E is equal to B minus C. I plug numbers in. So your 9.2% minus 5%, and E is 3.6% minus 5%, and this will give you the parts. So you have 4.2 parts for D and 1.4 parts for E. Next, we're going to solve for gallons. So here's your chart for the gallons. So D times gallons divided by the sum of D and E added together, and E times gallons divided by the sum of D plus E. So 4.2 times 250 gallons divided by 4.2 plus 1.4, and 1.4 times 250 gallons divided by 4.2 plus 1.4. So you do your multiplication and addition. So you get 1,050 gallons divided by the sum of the parts of 5.6, and 350 gallons divided by the sum of the parts 5.6. So you do your math, and you get 187.5 gallons for D and 62.5 gallons for E. Remember, if you look at the arrows, A is equal to E and B is equal to D when you follow your arrows on the chart. Therefore, you'd need 187.5 gallons of the 3.6% solution and 62.5 gallons of the 9.2% solution. And those together, when you add them up with your calculator, 187.5 plus 62.5, you would get 250 gallons. So that's not too hard of a problem once you kind of get your head wrapped around the way to do it. How many gallons of a 23.4% solution must be mixed with an 8.4% solution to make exactly 500 gallons of a 15% solution? So again, pull out your known and your unknowns. We have our little Parsons chart down here for reference again. So what we know is our solutions on the left, so A and B solution, and we know the solution we want to end up with, C. We know how many gallons. What we're looking for again is the parts, D and E. Go ahead and plug my known and unknowns in. So 23.4% for solution A, 8.4% for solution B. Again, you're looking to finish off with 500 gallons of a 15% solution. So we're going to solve for D and E, where D is equal to A minus C and E is equal to B minus C. So we're going to plug those numbers in. So 23.4% minus 15% and 8.4% minus 15%. You do your math. You get 8.4 and 6.6 parts. So D is 8.4 parts, E is 6.6 parts. And again, we're going to do our solving for gallons next. And to solve for gallons, it is D times gallons divided by the sum of D and E, and E times gallons divided by the sum of D and E. So you plug those in, so you have 8.4 parts times 500 gallons divided by 8.4 parts plus 6.6 parts. And for E, it's 6.6 parts times 500 gallons, again divided by the sum of 8.4 and 6.6 parts. So you go ahead and do your math on your top and bottom. So for D, you get 4,200 divided by 15. And for E, you get 3,300 divided by 15. You do your division, you get D is equal to 280, and E is equal to 220. And again, B is equal to D, and A is equal to E. So you need 280 gallons of the 8.4% solution, and you need 220 gallons of the 23.4% solution. And if you have done your math correctly, and you add those two together, you get 500 gallons total of a 15% solution. So that was just a couple of questions on mixing different solutions of different percentages to make a new solution of a desired percentage using the Parsons square. It's not too bad. I might put another video out on this later. Like I said, this is a study guide to learn the math. For me, if it helps you too, that's great. Thanks.